their SQL syntax is essentially, syntax is a block of code. That's all it is. What is your syntax doing? What is your code doing? That's all I'm asking. So here we have what is called our DML languages, data manipulation language. When you see DML languages referenced, when you see that verbiage thrown around, this is all it's talking about. This is it. It's either one of four of these things. If you are navigating within the space of SQL, you're doing one of four of these things. And 99.9% of the time, this is what you're going to be doing. However, I teach all of it because when they say the DML languages, they're referring to all of it. So I think it's important for you to know about it and important for you to know how it is applied. The reason why is very uncommon. I have in the past as a data analyst, just depending on like how the teams are structured. But the reason why it is very uncommon for you to do these type of things is because when you insert, update, or delete, you're essentially impacting the full database. And they can have some impact on like your data integrity and things. So typically your permission will be select, but like I said, I do talk about all of it. So let's get into the structure of your database, the structure of your syntax and how it has to be structured. So everything that we do within SQL goes back to tables. Here we have our select statement. We have our, what is this? It's a star. So select star, when I put select star, this star essentially means a wild card. I want all the data. I want all the columns. I want all the records. Give me everything. Select star from your table name. You are always pulling from a table. Your from always goes after your select statement. Always. Anything you expect within your output. When I say output, I mean your data set. Anything you expect within your output, you put after your select. Select this column, this column, this column from this table. Insert. Insert adds new data to their database. Now, with your weekly coding challenges, you have to create your table. Then you turn around and insert data into that table. This is what you're doing. I give you the syntax, but I give it to you, but just look at it when you execute it. Insert into this table name. These are your columns. These are your values. Your values and your columns, they got to match. They have to match in order. If I say customer ID, this is customer ID first name, this is my first name, last name, this is my last name. They have to match in order. And then they have to match in data type. That's where that data type comes in, because if I try to insert, for example, if this customer ID is an integer and I try to insert a varchar within that data type, it's gonna fail. So that's where that data type come in. Update. You are updating existing data in the database. Update, table name, set this column equals 993. Set this column to the updated value where this condition is met, where this column equals this. This where is called a condition. Going forward, this is how you filter your data also. If I say select all my columns from this table where this condition is met, where is called a filter, because I have to be extremely specific on what I'm trying to do. Update, table name, set this column, because everything goes back to either table or a column. I can't do nothing if I'm not talking about a table or a column. Set this column equals 993. Set this column to this value where this column equals John, where this condition is met. So this syntax will update the customer table and it'll set that customer name to 993 where this condition is met, where the first name equals John. Delete from this table name where this condition is met, where this column equals John. Get him out of there. Now, let's get into these colors. Select from, insert into. All of these that you see are blue are called reserved words. When you are communicating with your database, when you're communicating, when you write your code, when you write code, that's what you're doing. Which is also why you have to be explicit about what you're trying to do. Because it doesn't really, the way that humans process things, and we like, oh, well, maybe she means this, or maybe he means this. Data and code doesn't work like that. It's extremely specific. So when I'm communicating with my code and I'm telling it what I needed to do, these reserved words essentially have the expectation that something is about to happen here. So that's why it's blue. It's no different than you have a reserved seat for a wedding, or if you have a if you're communicating something, you use a certain language, it has the expectation of something is about to happen. So this blue, these are reserved words. Update, that's pink, that is a function. That means it changes the way that it is structured. Where this column equals John. Delete from this table name where this condition is met. So yeah. Any questions?
What was the term you called the pink font?
A function.
Okay. Thank you.
You're welcome. So, okay, perfect. Now let's get into our actual database.
I have a question.
Mm-hmm. I'm listening.
So when I get into the remote desktop, am I supposed to click on the SQL Server Management on the left to get into the database?
Yep.
Okay, just making sure. I don't think I made it that far.
You're fine. So let me get into the architecture. This is all my code from previous sessions. So I'm starting from fresh. Okay. So here we have, okay, so let me know when everybody gets to this screen and we can start from there.
I'm there.
Okay.
I'm there.
Okay. All right. So let's get into it. So what you're looking at now, and if you had any files up there, click do not recover because you're going to write your own code today. So here on the left, we have our Object Explorer. Regardless of whatever the whatever dialect you're in, your code will always be stored in this Object Explorer. Like I've done it in Oracle, AWS, GCP. It's always on this left over here. And what that Object Explorer does is it essentially houses your data. Now, this right here, this top part is your server. The server is what houses, it's essentially the brains of the entire database. And in an environment, in a organization, there are multiple servers. Like they might have production. Production is live data. That production data is what is connected to dashboards, apps, all of that stuff. That's production data. Then you might have like QA. QA is like used for testing or sandbox, or there's different environments. That's essentially what that server is. Server is the brain of everything. And when your server is down, the whole system is down. It doesn't work. So now if you expand your server right here, it'll open up all these different folders here. Now, within the server, you expand that, then you get into your databases. I have more databases because I use this for like other stuff too. But when you expand this, these boxes here are called databases. This is where your data is stored. And like how we talked about earlier, what is a database? This is a database in this functionality. Now, for the purpose of our session today, we are going to go within our data analytics simplified database. So expand that database here, and it expands it further. Here you will have your tables, your views, programmability. I'm going to talk to you about all of that. However, through the purpose of the course, we are going to do, we have tables. In one of our sessions, we actually do create a view too. So you do learn about those. Programmability is when you get into stored procedures. That programmability function, I don't have any stored in here, but that programmability function allows for those stored procedures to be stored. And what is a stored procedure? A stored procedure is essentially a block of code that you create that you can set a job to automate, and it runs on whatever cadence you need it to run. And let's say that you are in a position, like one of my positions, I was focused on data quality. So within the way that I tested that data quality is I wrote a stored procedure to check multiple tables for like data dependencies, data contingencies. And I'm gonna talk to y'all about that as well. But instead of me every day having to go and write my code, or every week, because it was a weekly project, I created a stored procedure to automate that. So that therefore, over time, I was able to increase, like, okay, I got one client, started out with one client, then over time, it just increased to multiple clients. So that's what a stored procedure is, essentially like an automated job, but with your code. Also, let's say, like I mentioned earlier, about how dashboards and things can be connected to your server. Let's say you have a stored procedure that is populating a dashboard, and you want that data to be refreshed, every time they refresh their dashboard. That's what their stored procedure, it automatically has like all your code there. You don't have to keep going back and like writing it manually. So let's get into our table. So expand your tables. Mine is taking all day to expand.
Sorry, Loretta. I just have a question. I'm just looking for the table. Was it a separate email that was sent?
What table? With the store
for the SQL.
The
screen that you're on now.
It's in your virtual. It's in your VM. You gotta connect to your VM, and the SQL server will already be installed on there.
Okay.
Were you able to connect?
I'm looking for it now. I'll find it.
Just click on start and then click on type remote RE and then do remote desktop connection. And then put your IP address for your computer name and your username. Put it here and then connect. And let me know if you need anything, but just essentially because you have a Mac, right?
No, HP.
Oh, okay. Oh, well, I'm sorry. I meant Windows. You have a Windows, right? You use Windows and not Apple. Yeah. So
Yes, Windows.
yeah, so click on your start and then just do remote and then it'll pop up. And your computer name is the IP address and your username is your username. And then when you click connect, it's gonna ask you to type in your password.
Thank you.
You're welcome. So this is your database here. We're gonna start with this one because it's the introduction course. So expand your tables, and these are your tables. Now remember how we talked about the different data types. These are your different tables. Now, as an analytic professional, when you get your role, when you get your job offer, your very first maybe 30 days, naturally within your role, of course, HR stuff, your benefits and stuff. But another big part of you navigating into that space is your actual getting up to par with the database, getting your appropriate permissions, making sure that you have access to everything, but also getting familiar with the actual data itself. And what that looks like is going in, connecting, and doing some data investigation. Now, we have our tables here. You expanded your tables. These are your tables. The first thing that you need to do is expand these tables, expand the columns, and look at the actual columns within these tables. Expand the tables, expand the columns. This gives you the opportunity to do your data investigation. Expand all of these. Because within this database, we have 3 tables. So expand the ones that we have and just do some looking around in there. Pay attention to your data types. These are those data types. And another thing that you need to do is pay attention to the way that these tables are related. What do I mean when I say are related? Just like how you would use it in your natural language. What is a common column between these tables? Because it's important for you to start naturally looking for those data relationships, because that helps you build relationships. And when you get to the point we have to get into our joins and our data dependencies and things like that, that foundational understanding helps support that thought process. Now, we have our tables here. Now, if you look at these tables, my mouse, oh, there you go. What do you think that these relationships are between these 3 tables? Looking at these columns.
So wait a minute, which one are you on? It's kind of blurry on that side. So which one are you under?
The Data Analytics Simplified database.
Okay, I'm gonna do that.
So expand the database and then expand these tables, the tables.
Okay.
And then when you expand the database and then expand the tables, it'll open up and it'll look like this.
I see system tables.
You want to share your screen?
I'm not. Let me see. Let me move it over. How do I move it over?
You got to click share down at the bottom.
Okay, I see it. 1 second. What do you want to do?
It's just right here though. You click on the tables and they just all show up. Let me stop.
Okay, can you see it?
Oh yeah, there they are right there. Courses, enrollment, those are tables. Courses, enrollment, students. Now click on your columns.
So click right here.
No, click on your, you see your table, courses, under your table name, click on columns.
Oh, okay, got you. Okay.
Now that is your columns. Now open up and expand those columns for each of those tables. That will give you the opportunity to look. No, go down to the next table, enrollment.
Oh, wait a minute.
Close it.
Oh, right here.
Yeah,
Enrollment.
yeah.
Oh, okay.
Now look. Yep. So those are your tables. So go up a little bit, and let me use you while you already on there. You finna be the star student. Okay. So within our database, we got our database. And then within our database, we have our tables, we have our programmability, which is like our store procedure. We got all of it. What you're in right now are the tables. Remember, anything that we do within SQL goes from tables and columns. When our data is stored on-prem, it's stored in these tables. So those tables is where the actual data is housed. Now, okay, you see how you have expanded your columns. When you are doing your data investigation, it's important for you to pay attention to, firstly, the relationships between the tables, and secondly, the data types, because data types are extremely important. Remember how we created table and then I had like integer, varchar, all of that stuff. That's where those data types come into play. Now, you see your course ID. That is a column name within that course table. Now, we got course ID, PK. What's PK? PK is primary key. That means that that column is a unique identifier in that table. Integer, it is int, is the integer. Now we got course name. Course name, varchar 100. So we have a variety, that's a varchar data type, but it can't be any more than 100. Now expand your enrollment table and expand your columns again. Perfect. Now look at your, scroll up a little bit so you can see your students table. Okay, cool. Now you see how enrollment ID, that is also a PK. That is a primary key. That means that that enrollment ID is a unique identifier for that enrollment table. Only it's a unique identifier, so there can't be duplicates of that particular column. So that's what that means. INT, integer, not null, means that it's also a required field. Where you got null in those other columns, you can get away with not inserting data in there, but you have to have data within that data type, within that column. Now, look at your course table and look at your enrollment table and tell me what you think the relationship is between those two tables and why. Or anybody can chime in.
It's a course ID?
Mm-hmm. Yep. So let's talk about that. So you see that the course ID is from that course table. The course ID also exists within that enrollment table. But in the course table, that course ID is a primary key. That is my unique identifier within that course table. You get down there to that enrollment table, that course ID is a foreign key, FK. FK, foreign key, means that that column is a primary key to another table. When something is foreign, it's not from there. It's a primary key, but it's not to this table, it's to another table. That is those data relationships. Now, when we talk about data dependencies, a data dependency is this data essentially depends on this data to exist. That's where that's where you get into like data mapping, data quality. That's when all of those things are tested, because when you are creating and inserting data within a database, not only do I create my tables, but I have to assign the data types. How we did create table, table name, column name, data type. You're assigning those data types for a reason. And the reason being is to firstly to keep that data organized, because y'all remember that was the main part of the data of the database. Keep the data organized, but also keeps it structured so that when that data depends on another data, you're able to have quality data. If someone can just come, and if I can just come and insert 2 million records of data in here and I don't create relationships between the other tables, it's about to be a mess. So when your databases are created to have that high data quality and that high referential integrity, it has to be explicitly labeled. This table depends on that table. This data has to exist and it has a relationship between this table. Because if not, you can have 30 tables with just random data and that's trash, basically. You can't do anything with it. I can't test it to see if it's clean. I don't know what the relationships are. So that's why you, as an analytic professional, go through, do your data investigation. And not only do your data investigation, but try to get an understanding of how those data, how that data is related. Not only the data relationships, but how each of those tables depend on the next. What are the data dependencies? And that foundational understanding will help you navigate this space to make sure that you understand, like, these are the dependencies. This is the primary key. This is the foreign key. People love asking that question in interviews. That question, what's the primary key? What is a foreign key? A primary key is a unique identifier in a table. It's unique. It makes each of those records a unique record. A foreign key is a unique identifier or a primary key within another table. That's data relationships. Tuck it away because people love it. They love it. And just ask, like, what's the difference between those? So scroll down a little bit. Whose screen is this? Ramonica, this is your screen, right? Yeah, scroll down a little bit, Ramonica, and let's get into this third table down here. Students. Now expand that one and expand those columns. Now, what are those relationships?
Student ID.
In what table?
And enrollment.
Very good.
And students.
Very good. And okay, perfect. Yep. And that's where those data relationships, this table relates to this table. That's where you also get into like data mapping and how they relationship. All of that verbiage stems from this type of work. What's the relationships? How do they exist? What are the dependencies? Does this data depend on this data? What's the referential integrity? Are there any, is this clean data? Because the gap is always, even when people ask, okay, they say, okay, well, we have so much data. We have so much data. The goal is not volumes of data. The goal is clean data. If I got trash, if I have 5 million records and it's trash, I can't make sense of it. I can't create relationships. My analysis is going to be trash. If my analysis is trash, my recommendation is going to be trash. If my recommendation trash, what's the impact of it? I could have easily recommended something and it's not a true representation of what the data represents. So that's where that knowledge comes into play. Okay, is this clean data? Is this quality data? And just get in the mindset of checking it and looking for it and asking those type of questions, because the difference between somebody that's just a baseline analyst and somebody that adds value and that is impactful, you ask those type of questions. Go in super curious. Okay, so what is the relationship? What's the dependencies? I'm doing some data investigation and I see here. And that's how I want y'all to be cultivated. That's why I push y'all in this way to empower you to have those thoughts. So now I'm gonna share my screen. Thank you, Ramonica.
I have a question.
Okay.
Now, once we're on the job, how and we do the research looking at the different tables, how will we know what's the primary and foreign key? Will it be labeled?
Like this, like looking at the, yeah, you see my screen. Like this, it'll be this PK.
It will already be labeled.
Yep. Now, there are times to where I've done it both. Now, in my experience, I've done it both. And what I mean by that is I've been a data analyst and I've had to create tables and keep up with the database architecture and things like that. I've done that before. But within that was only one role. And the reason why it was set up like that in there was due to the way the organization was set up and the team was set up. But most of the time, when you are coming in as an analytic professional, those tables and things are already defined. And you have to come in and get familiar with that data and know how to navigate and know how to like source out those relationships, which also goes in a play of like we haven't had our career coaching sessions yet, but one major thing that we talk about in our career coaching sessions is the ability to lean in on your domain and existing knowledge. What does that mean? That means that if I am in public health, let me stay within public health and go within analysis over there, because you have the business knowledge and you have the domain knowledge. And with that, you're able to have some sort of baseline of like expectations of your data.
Okay.
So yeah, go in, and most of the time the data is already defined by like DBAs, data engineers, etc. But there might be, just depending on how that team operates, to where you have to do it. But if you have to do it, then that data, in my experience, might not have an impact. Like it's not used for like apps or front facing or client facing. It's like a database that like you and your team uses. So, but yeah, it's just identified right here.
No, I'm sorry, I didn't mean to cut you off.
You good?
So my question might be kind of related to hers. So basically, say for instance, I'm working for a company and I'm working on some data for a project. And then I'm done with that project, and then I need to jump onto another project that has a totally different set of data. How do I tell the difference as far as like when I come in? How do I know which data set was for which? You see what I'm saying? Like,
yep.
Are they stored in places?
Yep. Sometimes. Okay. So let's get into that, because that what you're asking high key still relates back to data architecture and why. So let's talk about it. So let's do it like this. I'm gonna actually walk you through it just like this. So here we have our database. Typically, the way that databases are structured and they are set up is data is like organized by database for whatever the need is. Sometimes, most of the time, supposed to be, but that does not mean all the time. So your data could ideally be structured by database. So these are your databases. Now I'm about to right click and I'm about to select my top 1,000 rows, and then I'm gonna take it a step further with you. So here we are selecting our top 1,000 rows. From when I right clicked it, it automatically pulled up the database. This is our database name. This is our schema. And this is our table. Now, let's say I have a database and I have 40 tables within my database. So I got my database and I got 40 or 50 tables within my database. However, 10 of those tables is allocated or used for one project. That is where you would change the schema. So it would have the same database, and then your schema might not be DBO. It might be like customer data. Like whatever, you can make your schema say whatever you want it to say. And what their schema does is it organizes those tables within their database. So that's actually a really good question, because that's when you get into like their organization and their architecture. Because when you get into schemas, it's essentially the architecture. If I change the schema of my table, it's going to change the way, like all of these are DBO. If my schema is like customer, it's in ABC order. So it's going to organize it, group it, essentially organize those tables by schema. So it's like server, you got multiple servers. Server is like the top. And then in each server, you got different databases. That's the step further. Then in each database, you got different tables. Then in each table, you can organize that down further by the schema. So like in your case, you say, okay, well, I had to do one probably about 2 weeks ago for a infrastructure project. Basically, like we're in the middle of taking the data and changing where it's stored, essentially. So it's going to be stored like in a different spot. So essentially all the data that is going to be migrated first, or essentially moved first, the schema had to be changed to reflect it. So all the data was stored within the tables, but even within the tables, you can organize it by schema. So, did that make sense?
Yes, it makes a lot of sense.
Okay.
That was helpful. Thank you.
You're welcome. That's a good question. Okay. Now, here I right click. The way that I got to this view is I right click my table. So y'all right click your table and select your top 1,000 rows and let's go within our students table. And let me know when you got it and we'll walk through what shows up on your screen.
Can you repeat that again?
Right click it. Yep. And then select top 1,000. Now, let's walk through what we were doing. Okay, so let's walk through what happened and what you see here. So you right click and you say select top 1,000. So select, this is our select statement. Remember, we are selecting data from a table. This is what you're seeing now. So we got select top 1,000 is a limit function. When you right click data and you select top 1,000, it's going to only pull the top 1,000 records automatically. Why? Because you might have 2 million records in your table, 3 million records. And it doesn't make a lot of sense to let you pull all the data unless you need it. You can always change this or just take it out. So we got our select top 1,000. This is called a limit. Now, if you notice that each of these columns automatically have those square brackets around it. Why? It has those square brackets around it because there are times to where your column names might actually be a reserved word too. But if I put these square brackets around it, it says this is actually a column, not a reserved word. Let's say you have a column named status or a column named something that is also a reserved word. This allows that to be identified as a column and not a reserved word. So select top 1,000. These are our columns. Whatever we have in our select statement is what shows up in our output. Y'all see this, the output right here all day long. Whatever we have in our select statement, we are selecting this column, this column, this column, this column from this table. It's going to show up in our output. Now, let's say that I'm going to remove this top 1,000. Let's say that so I'm do some spaces here. And let's say how I told y'all about documenting what you write, what you documenting your code. The way that you comment out your code is you do the 2 dashes, or you can do it like it is at the top. You can do the 2 dashes, or you can do backslash, square, star, star, and backslash, and whatever is in between here is commented out. This is how you document your code. Essentially, this is how you capture what you're writing in your code. Let's say that you are creating a store procedure. You have 50 lines of code, 60 lines of code, 400 lines of code. I've written 500, 600 lines of code. you have to be able to go within your data or go within your code and be able to say, okay, this is what that was doing. Or if somebody coming to look at my code, like, this is what she was doing. It just helps like create clear business documentation. So I two comments and say, this query does X, Y, and Z, whatever you're doing, whatever your analysis doing, or whatever it is, this query captures this, whatever, just to keep your stuff organized. So we are selecting these columns from this table. This is the database, this is the schema, and this is the table. That goes into that question that Monica asked just a minute ago. Well, how do you keep it organized in the table? In the database, if we doing different stuff, just like this. Now, this is your select statement. Anything that we're going to be doing from this moment on, this course on, today, this session, every single thing we do is going to build upon what you learned today. So remember how, I'm going to move this out the way. So remember how I told y'all how this is called a condition. It's saying delete from this table where this column equals this. This where statement is called a condition. When I say where, I have to specify which column I'm applying the condition or the filter to, where this column equals John. Notice that within this example, I got John and I put John in the single quotes. That single quotes changes the data type of my code to a string or a varchar. So whenever I have something that is not an integer, I have to put single quotes around it to identify this is a string. So were y'all able to select your top 1,000 rows? So I am about to give you all your first use case. I'm going to type it in chat and I'm going to say it out loud because the chat is not accessible like on a recording. So I'm going to type it in the chat and I'm going to say it out loud and then we'll walk through it. So this is your data request. I need a list of students that have a major of computer science. So within you, the first thing that you're going to do is do some data investigation. You're going to go and you're going to look at your tables and say, well, which tables answers this question? And the way that you can do that is look at your tables and look at your columns. Now, within this one, we are only using one table. We're not going to start using more than 2 or 3 tables together, probably like in our third session. But so this one, all your data will be retrieved from one table. So I need a list of students that have a major of computer science. Now, in order to give me a list, I'm asking you to retrieve that data. So when we are retrieving data, which of these do we need to use?
Select.
Yeah. And then if I say a certain criteria, that requires you to filter, select whatever columns you need from this table, where this condition is met, where this column equals this, whatever. If I need a list of students that have a major of computer science, I need to use my select statement from the table and then filter out my data based on those conditions. And if you want to talk through it.
Are we creating the syntax?
Yep.
Or are we just giving you?
No, you write your code. Select your top 1,000 record. Go through and do your data and go through and expand your table so you can see the columns in there. And when you see the columns in there, that when you expand your columns, that is your data investigation. You're doing your data investigation then. because you get you got a qualitative X when you are within your space or when you doing your code and your technical assessments to get your roles. The way that they're going to be formatted is somebody is going to come and they're going to ask a question, a qualitative question. How many students did this? Well, how many did that? Can you give me a list? So you get a qualitative ask. Your first step is data investigation. Which tables answer these? Which tables answer this data? Answer this question. When you do your data investigation and you expand your column, then you like, oh, okay, it has to be this table. Then you right click on that table, select the top 1,000 rows. Go over here. Right click on the table, select your top 1,000 rows, and get rid of your top 1,000 because we want them all. We don't want just 1,000. We don't want a limit. So get rid of your top 1,000. And it's not this table. So get rid of your top 1,000. Give you a space. Document out your code. This query retrieves all students who majored in computer science, or whatever your analysis is, and formulate your code to answer their question. So first, data investigation. Which tables answer this? And remember, when we're filtering, we have to say where. Select this column where this condition is met, where this column equals this, where that column equals that, or whatever those conditions are. You have to identify those within your where statement. Those are called filters and conditions. I'm choking, y'all. Ain't nothing wrong with me. Carla, did you get it? While they working on it?
I have to download something. I'll do it after we're done.
Okay.
Thank you.
You're welcome. And put some time on my calendar this week, Carla.
Will do. Thank you.
You're welcome. What did you have to download?
It's saying that I have the Windows 10 Home. I need the Pro. So I have to upgrade to that.
Oh, you got to upgrade. Oh, man. Yeah, put some time on my calendar this week. We'll talk through it.
Okay, thank you.
You're welcome. And this recording will be at your dashboard too, Carla. Is anybody brave enough to share their screen?
I'll try it.
Okay. I'm going to stop sharing and we'll walk through it.
I don't think I did it right, but I'll give it a try.
It's okay. That's why we're here. So I'm going to put you on a big screen so I can see what you're doing.
Okay. Can you see it?
Mm-hmm. Okay, I see. Okay.
Did I do it right?
Kinda. So let's talk about what you did. So line 1, perfect, 100% correct. And the reason being is because you are documenting. This is top tier documentation come through. Period.
Okay.
Now, really, what you could have done is just put select on line 3, and you didn't have to redo it on line 9 because it already exists. Oh. And if your code, if your code already exists, what you could do is essentially build upon the existing code. So put your select statement up there.
Select.
And now, comment out on line 9. Just put your 2 dashes in front of line 9 so we can just act like they don't exist.
Okay.
Okay. Now, what? Yep. Get rid of that comma on line 4.
On line 4?
Yep.
Okay.
Yep. Okay. Perfect. Now, execute your syntax. Press that execute in that top, that green button at the top in the taskbar.
Right here?
Yep. Nah. Yep. Okay. Perfect. Now we see that this exists. Or we see that this compiles correctly. Compile essentially means run. We see that your code is compiling. That is what we want to do. Right now, you are getting the first name, last name, enrollment year, major from the students table. Okay. Now we want where the major is computer science.
Mm-hmm.
So as a matter of fact, just get rid of line 9 because I don't want to confuse you. Just delete it.
Just how do I delete it? Just exit.
Regular.
Like that?
Yeah.
Okay.
Now we have our press there you go.
Right here.
Yeah. Perfect. Now, whenever we are being specific in what data set we need, that requires for us to filter that out. So you got this is 100% correct. Now, your next step is you need to say where. Whatever you're trying to filter. If I say I need all the students who the major is computer science, what column are you using for your data set? What column do you need?
Major.
Yep. So go on line 9 and put your filter where. Yep. And then your column name.
In the brackets, right?
Yep.
Equals
Mm-hmm.
computer science.
Mm-hmm. Put your single quotes around computer science because we want to turn it into a string. Now do one quote. Yep.
Okay. I'm surprised it didn't pop up.
What the
like how it pops up for the rest?
Well, the reason why, and you ain't gonna return back no data, and I'm gonna talk about that too. The reason why it did not pop up is because, okay, so where major is a column, but the computer science is actual value within the column. So it's gonna pop up your like tables, columns, but it's not gonna pop up your actual value.
Okay.
Now you're not gonna return any data, and the reason being is because do some data investigation and look at the way that your data is structured within that column table. Within that
is it because the spaces?
No. Look at the data, look at the word.
Oh, I had an S behind.
Yes. Now execute it.
Go back. Delete that. Oh, execute in the green.
Yep. Oh, you need to quote. You need to close your quote. Oh, look. There you go. Perfect. Now, you actually did a very good job because you had already. I think the way your brain was working, I be trying not to like tell y'all what y'all thinking, but from the looks like, to me, it looks like you tried to reinvent the wheel. You are, yeah. You very much so did. To me, that was evident. When you already have something that exists, let's say I have code that is similar to what I'm trying to do, you do not have to reinvent the wheel. Use what you already have and build upon it. It's no different than you waking up in the morning and you getting dressed and you like, okay, well, let me layer this and let me layer that. It's essentially the same thing. And that's why I want y'all to not get in the habit of memorizing, but get in the habit of thinking through and applying. Because I looked at that and was like, she tried to start from scratch and you didn't have to.
Okay. Gotcha.
But you did really well. Can you walk me through what your code is doing?
What do you mean? Like the okay, so the from is basically the statement that's going to basically give the action of what it's about to do, right?
Or where? I mean, yeah, it's like, well, where is filtering, but your from, anything after your from is your table name, like what you have.
Okay.
Don't overthink it. You finna overthink it. Walk me through what
But
your.
my business telling me where to pull the information from that I specifically want.
Yes. Yes. What is that on line 8? What is that from? What's after that from? What is it?
The table. That
Yes.
I mean the database that I want to use. Right?
Yep.
And then the table that I'm taking it from.
Yep. What are those on line 4 through 7? What is that?
Those are the I guess the data points that I need to pull the information as far as like the students, the list of the students.
Yep.
To describe those students, the first and last name.
Yep. What is that on 9?
The reserve words. I guess the reserve words.
It's a filter. It's a filter.
Oh, it's a filter.
Yep.
The red letters are the string that I want.
Yes. 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 Very good. Very good. Very good. Very good. Very good. You did exactly what you need to do. You got your documentation up there. It's super clear. That's good practice. Now, if I don't want enrollment year. So how would you navigate that? If I only need the first name, last name, and major, what would you do to your code?
Delete column 6.
Yep. Or either put 2 dashes in front of it. But yeah, that's exactly what you would do. Yep. Good job, Monica.
I have a question.
Okay. Do you want to share your screen?
Let me start.
It's the same thing you have actually.
Oh.
The same thing Monica has right now.
Okay.
So I did write this query the way you wrote it, except I had student ID up there.
That's fine.
Okay, and then I put a period at the computer science. I don't know why, but.
And I know you didn't get no data, did you?
No, and I didn't have the equal sign.
Yep. When you do your data, investigation, the structure that your data, the way that your data is housed in that table, it has to be explicitly housed just like that within your code. If not, it's not going to return. Just like how Monica had an S, it's not going to return.
In the comma before first name, you said to delete that. I had the comma there as well. It's like little things.
But you had student ID though too, Lisa, didn't you?
I had student, yeah. So
you
am
need
I supposed to remove that?
She removed her comma because that was the first column. She don't have anything in front. So essentially the way hers was written, it was like select comma, then her column name. But since you retrieve your student ID, it's fine. If she was to put student ID within hers, she would have to put another column in front of there.
Okay.
Yep.
I have a question. So you said that like we're gonna build off of this. So when we get ready to build off of this, like when we get ready to do like our challenge, right? So do we just keep going and like is it gonna give us the same thing again, or we're gonna have to build those from scratch?
Yeah. So your challenge will be in a different environment.
Oh, okay, gotcha.
Yeah. But when I say build off of it, think about like how you just did this one. Like if I select my top 1,000 rows and I need to say from this table, where this table, how you went and you were about to write all that over again. You don't have to do that.
Oh, got you. Okay.
Just
okay.
Keep what you got. And in the event, even as we progress and we do logical operators, joins, CTE, like when we get into complex, don't ever feel the pressure to like start from scratch. Never. I still don't even do that now. Like if I do the way that I do it is like how I teach y'all, like I select my top 1,000 and then I like build upon it. Like how you had your select, you had from code from line 3 to 8. And I was like, okay, first let's execute that. And you executed that, then it worked. Then you go and you add something else. You execute that. Like that's essentially how I write code.
Okay. That's helpful. Very helpful.
It
takes a lot of
pressure. Yes. Yeah. Don't ever feel like that because it's very it's totally acceptable. Like it's totally acceptable to build upon your code. Any other questions?
I have a quick question.
Okay.
Now the comma, I see you have that first instead of behind. Does it matter if we put the comma before?
No.
Okay.
Some people, the way that it's structured within the database, like, oh, I'm not sharing my screen. The way that it's structured within the database is it automatic